Hi, my name is Taylor Foote. My presentation today is based on linear algebra and physics. One of the most basic concepts you learn about in linear algebra is vectors. Vectors appear in a number of different forms in physics. The most common forms vectors appear in are through velocities, forces, and magnetic and electric fields. All these concepts are taught in even the most general physics courses, and they all take on the form of a vector. The first vector learned about in physics is velocity. In a real-life situation, wind would not have a serious effect on the rocket traveling into space, but this is a very common, simple question that is asked in general physics courses. A rocket is traveling at 150 meters per second in the northeast direction. Wind is blowing at 20 meters per second in the west direction. What would the resulting speed of the rocket be if the wind had full effect? The first equation shows how to obtain the velocity of the rocket in the north direction, while the second equation shows the velocity in the east direction. These values are found by multiplying the magnitude, or length, of the vector by their respective cosine and sine values. For the north direction, you would use the sine of the given angle, 50 degrees, and for the east direction, you would use cosine of 50 degrees. Now that the vector is broken into component form, the wind velocity can be combined with the rocket's east velocity. Because the rocket is traveling east and the wind is blowing west, the wind speed is subtracted from the rocket's eastern speed. This calculation is shown in equation 3. This new rocket speed in the east direction and the rocket speed in the north direction can be recombined using Pythagorean theorem, as shown in equation 4, to achieve the final rocket velocity. The resulting vector has a magnitude of 138 meters per second as opposed to its initial velocity of 150 meters per second. The second most commonly taught vector form is forces. A free body diagram is shown on the car at the left. The force of gravity, denoted by F sub g, is pulling down on the car, while the normal force, denoted by F sub n, is shown pulling upwards on the car. The force of friction, shown by F sub f, is pulling the car to the left, while the force of the car's gas pedal is shown F sub v, is pushing it forward to the right. As shown by the vectors, the normal and gravitational forces are in opposite directions, and the force of the gas pedal and the friction force are in opposite directions. The normal force is equal and opposite the gravitational force, as the car is planted firmly on the ground and not floating into space due to the gravitational force, yet not being crushed to the earth by the normal force. This is shown by the equal lengths of the normal and gravitational force vectors. The frictional force is not equal and opposite that of the force of the car's gas pedal, because the car is being pushed forward to the right. This is denoted by the larger vector corresponding to F sub v and the smaller vector corresponding to F sub f. Lastly, vectors are used to show magnetic and electric fields. In the first image, the blue vectors show the force of the point charge in the upwards or positive y direction, while the red vector shows the force of the velocity in the left or negative x direction. The magnetic field is shown by the circle on the point charge. In 3 dimensions, the magnetic field vector would be pointing in the negative z direction, but because the image is 2-dimensional, the circle shows the magnetic field as coming out of the point charge towards the observer. The magnetic field of a coiled wire is also shown in image 3. The red vectors denote the direction that the current is moving counterclockwise. The blue vectors show that the magnetic field is coming out of the coiled wire in the upwards direction. The second image shows a positive charge and its resulting electric field. The electric field vectors point away from the positive charge, perpendicular or orthogonal to the positive charge's surface. If the charge were negative, the electric field vectors would have the same magnitude, but they would point inwards towards the point charge. Shown here are my works cited page, and I hope that you enjoy my presentation.